Alright, I got cut off on my timer on the last video, so we're picking up right where we left off in example 2. So we're doing f of x, we're doing the rate of change. We got 150, 250 for the first point, and then so at 150 minutes, there's 250 bacteria. 210 minutes, there's 1,000 bacteria, and so we were using that to calculate the average rate of change. We got 760. So what we're going to do now is divide that out. So 750 divided by 60, and you get 12.5. Okay, so that is the average rate of change. Now, to find it for the other one, we're going to have to go back and actually plug in some numbers to be able to calculate that. All right. So in g of x, so I'm going to do the rate of change here as well. So I need my points. So first off, if I plug in 150 into that equation, 8 times 2, 150 divided by 15 is 10. So to the 10th power, I get 8,192. Okay, and then if I do the next one, if I plug in 210, all right, then when I simplify that, that ends up being 8 times 2 to the 14th, which is 131,772. Okay, and again, all I did to get this number was 8 times 2 to the 210 over 15. And then that part right there is 14. So 2 to the 14th power times 8. Okay, you cannot do 8 times 2 first. All right, so now to do my rate of change, okay, I'm going to do 131,072 minus 8,192 over 210 minus 150. You can do that all in your calculator. No need to stress out over it. But what you get is 122,880 divided by 60, which turns out to be 2,048. Now, when you're comparing those numbers, the rate of change is much steeper, okay? So in other words, this graph is increasing at a much faster rate for g of x as opposed to f of x, okay? Even though they start off in the same place. So obviously, whereas this one is doubling, even though we don't necessarily know exactly what the rate of change is for the graph over here, or the base that we're going up to a power of, it's obviously not double. It's obviously not going to be 2, okay, because it's not going up that fast. All right, so we're going to now move on to the last example here, and clear my ink. Sorry about that. One sec, guys. All right, so last example, we don't have a graph this time. We're given tables, and we're going to have to use that. So a pendulum swings 90% of its previous height. Pendulum A starts at a height of 50 centimeters. All right, so they gave us the function for f of x. So f of x is 50 for the initial height, and then we're going 90% of that after each swing. Okay? Now, of course, swings are not timed. So this is one example where your exponent necessarily won't be timed. The intervals is each swing. So the height after every 5th swing of pendulum B is recorded in the following tables. Compare the properties of each function over the interval 5 to 0. So the first thing we want to compare is the initial value, right? So the initial height for f of x, I guess I'll call this g of x then. Sorry about that, since this is f. So the initial height for f of x is 100 centimeters, okay? As compared to the initial height of 50 centimeters for the other one. So this one starts at a larger height, right? The table starts at a higher point. All right, now, what's the rate that's decreasing? Well, can we figure out which one's decreasing faster? All right, so what we would do then is plug in our points into the function that it gave us for g of x, but then we can also just pick our points out of the table from f of x. So we're looking for 5 and 15. So I care about this point, and I care about this point. Okay? So my rate of change, the first one, is going to be 20.59 minus 59.05 over 15 minus 5. Okay? And when you plug that into the calculator, what you are going to get is negative 38.46 over 10, or negative 3.4846. Okay? So that's the average rate of change for that first one. Now to go to the same thing with g of x, we got to get those 2 points. So the first one would be if I plug in 5, what am I going to get? And if you plug in 5 into that function, you get 29.52. If you plug in 15 into that function, you get 10.29. Okay, so average rate of change would be 10.29 minus 29.52 over 15 minus 5. Okay, again, plugging all that into the calculator, you get negative 19.23 over 10, which is negative 1.923. So what that should show you is that this one is decreasing at a faster rate. The table is decreasing at a faster rate. So in other words, the pendulum is not going to be, the number here is not going, it's higher. Okay? It's closer to 0 for the table. It's closer to 1 for the f of x function. Okay, because it's decreasing faster. Alright? So using those examples, we'll do some more practice with it. Try 351 and 352 today in class, and work on the wall to try to get them done. Alright, good luck, guys.